Welcome to the Deep Dive. I'm your host, and today we're getting into something really fascinating.
Glad to be here. I'm your resident expert for today's analysis, and I've been digging through our sources all morning.
Awesome. So I want you to imagine, just for a second, that you are standing in the middle of a massive, sprawling city.
Okay, picture that.
You have these huge skyscrapers towering over you, millions of moving parts, constant traffic, horns blaring everywhere. And right in the middle of all that overwhelming chaos, there is a single, slightly leaky pipe.
Just one tiny pipe.
Right. Most people walking by wouldn't even register it. It's just a tiny drip on the pavement.
Yeah, completely invisible noise.
Exactly. But then someone stops, opens up their toolbox, and carefully, meticulously fixes that one specific pipe.
Wow.
And they don't just fix it and walk away. They pull out a notebook, write down exactly what wrench they used, the size of the fitting, they date it, and they file it away.
When you frame it like that, it sounds almost, obsessive.
It really does.
I mean, a city of that scale, and someone is literally halting their day for a single drip. The natural instinct for most of us is to either just ignore the drip because it's too small to matter.
Right. Who cares about one drop of water?
Or to feel completely paralyzed by the sheer size of the city's crumbling infrastructure. Like, why bother with one pipe when the whole grid is a mess?
But what if that tiny fix represents a really profound philosophy of maintenance?
Oh, absolutely.
Like a way of looking at the world that can completely change how you, the listener, approach learning or problem solving and dealing with the constant barrage of information overload we all face.
Yeah, because it shifts the perspective away from the paralysis of the macro, right?
Exactly.
You stop worrying about the whole city and you just take absolute rigorous control over your immediate surroundings. You master the micro.
And mastering the micro is exactly what we are looking at in today's deep dive. We've got our hands on this incredibly detailed archive.
It's a massive source.
It really is. It's a 15-year log from someone who refers to themselves as an old software plumber, someone who just spends their time tinkering with free, Libre, and open source software.
FLIS, for short.
Right, flawless. And we are going to zero in on one single note from March 28th, 2026.
Which is just a microscopic change in a Haskell programming parser.
Yeah. But alongside that one note, we have access to their entire index of tags and project data, going all the way back to 2011.
And honestly, the sheer volume of that index is what makes this a compelling study. It's literally a data set of human focus.
So our mission today is to explore how making these microscopic, heavily documented improvements in a tiny piece of code actually reflects a much larger, universally applicable system.
A masterclass in relentless, iterative learning.
Exactly. Okay, let's unpack this.
So to really understand the overarching philosophy of this entire archive, we have to start by zooming all the way in on that specific leaky pipe you mentioned.
Right, the Haskell note.
We need to look at part 94 of their notes on Haskell programming.
Just the fact that there are 94 parts is a detail we will definitely come back to.
Oh, for sure.
But let's look at the actual fix first. The note in the archive is titled, Improving Chapter Number Identification with Data.Char.isNumber.
Right.
Let's just pause right there. Because for the listener who isn't a software developer, what does identifying a chapter number actually mean in this context?
Well, in the context of parsing a document.
Which means what, exactly?
Which essentially means writing a program that reads, analyzes, and understands raw text.
Okay, got it.
So the software needs to know how the document is structured, needs to know where a new chapter begins. And to do that, the code was originally using this built-in function called Data.Char.isDigit.
Which seems entirely logical. I mean, if you want to find chapter 1 or chapter 2, you tell the computer to look for a digit.
Yeah, it functions perfectly well if you're only looking at standard ASCII text.
The older text format?
Right, ASCII is an older character encoding standard that basically covers the keys you see on a standard Western keyboard, just the numbers 0 through 9.
Sure.
But the author of this log realized this approach was actually creating a blind spot in the software.
Because there's more out there than just Western keyboards.
Exactly. They wrote, I learned that the Data.Char.isNumber function can check both ASCII and Unicode full-width digits. This is a step up from Data.Char.isDigit, which only verifies ASCII digits.
I want to dig into that for a second because terms like Unicode and full-width digits can sound kind of like a foreign language.
Deep in the weeds.
Yeah. Why does the jump from ASCII to Unicode matter so much for a program that's literally just trying to read text?
Because the world isn't just written in standard Western characters. Unicode is the modern computing industry standard. Its whole goal is to represent every character in every language on Earth.
Wow, okay.
Now, if you are parsing a text, a chapter header might use a full-width Unicode digit. In Chinese and Japanese typography, for example, characters are often designed to fit into a uniform square grid.
Oh, right, because of how the symbols are shaped.
Yes, so Western numbers need to be stretched out or made full width to visually match the weight and spacing of those complex logograms.
So it's an aesthetic choice in the typography that actually breaks the underlying code.
Exactly the problem.
Yeah.
If your software only looks for skinny, standard ASCII digits, it goes completely blind when it scans a Japanese text.
Just doesn't even see them.
Right, it skips right over those full-width numbers and fails to recognize the chapter header entirely.
To fix that previously, the author had to write these manual custom checks to catch those edge cases. They had to instruct the program, look for an ASCII digit, or look for this specific type of full-width character.
Which takes more code, introduces a lot more complexity, and requires more testing to make sure you didn't accidentally break something else in the process.
Right.
We use the term refactoring in software. For the listener who isn't a coder, refactoring is basically reorganizing the plumbing of a house without changing how the sinks and showers look to the people living there.
Okay, that makes sense.
You're just making the system underneath more efficient.
It's kind of like swapping out a standard Phillips head screwdriver for a universal multi-tool.
Oh, that's a good way to put it.
Yeah, you don't just tighten the one screw in front of you. You suddenly eliminate the need to carry around 3 other specific clunky tools in your belt.
And the consequence of having that universal tool is that you get to delete code. You reduce the surface area for bugs to hide.
Which is always a good thing.
Always. By swapping isDigit for isNumber, this single native function call replaces all those manual checks. The author explicitly notes how satisfying this is. They call it a satisfying refactor that replaces our manual code with a robust existing function.
It's the deep satisfaction of discovering the absolute right tool for the job. But here is where I have to admit I struggle a bit with this source material. Well, it is one thing to have that realization right, to make a clever, satisfying little code tweak on a Tuesday afternoon.
Sure.
It is an entirely different thing to reach part 94 of a programming journal documenting those tweaks. I mean, I'm looking at these logs.
There are a lot of them.
730 posts in the year 2025 alone. Honestly, my first thought isn't admiration, it's exhaustion.
It is a staggering amount of output. By late March of 2026, which is the year of this specific Haskell post, there are already 261 posts.
Wait, really? 200 by March?
Yeah, that is roughly 2 entries every single day.
Right, so if you're a listener who's already drowning in emails, Slack messages, project updates, wouldn't writing down every single tiny fix feel like a second job?
I can see why you'd think that.
Like we see titles here saying part 74, add a debug. Wouldn't documenting a single line of code just add to the noise and clutter of modern life?
It is a very natural reaction to look at 700 posts a year and assume it leads to burnout. But that assumption misunderstands the actual mechanism of this documentation.
Okay, how so?
This isn't someone sitting down to write grand, sweeping, definitive essays on computer science. This is a living, breathing, iterative changelog.
A changelog, like the release notes you scroll past when an app updates on your phone. Bug fixes and performance improvements.
Exactly, but a highly personalized version of that. The psychology of microjournaling is all about reducing friction.
Reducing friction.
Yeah, the magic of a changelog is that it doesn't demand you hold everything in your head at once.
Huh.
By breaking complex, intimidating subjects into these daily bite-sized notes, the feeling of overwhelm is actually defeated.
So instead of sitting down and saying, I'm going to master the Elixir programming language today, which is terrifying and probably impossible.
Which invariably leads to paralysis.
Yeah.
You end up doing nothing.
Right.
Instead of doing that, you just tinker for an hour. You find one tiny thing you didn't know yesterday. You fix one leak in the pipe.
Just one pipe.
And then, and this is the crucial part, you externalize that knowledge. You write one sentence, you tag it, and you move on. The friction to hit publish on a note titled Part 74, Add a Debug, is almost zero.
You are literally downloading it out of your own brain so you don't have to carry the mental weight of remembering it.
Exactly. If you've ever tried to learn a new language or a really complex software tool at work and felt completely paralyzed on day 2, this changelog methodology is your antidote.
I could definitely use that.
Just look at the project tags in this archive.
Yeah.
We see this applied across multiple highly complex domains. Notes on Elixir and Erlang programming, notes on Python, notes on Rust, notes on Go.
These are incredibly dense technical fields.
Very dense.
People often use the metaphor of building a skyscraper, like placing one brick at a time. But looking at this 15-year archive, a skyscraper feels almost too rigid.
Too structured.
Yeah, it's more like growing a mycelium network under a forest floor.
Oh, I like that.
Each tiny note is a new root. On its own, it's microscopic. But over a decade, it forms this interconnected database that can nourish any new project you plan in it.
That is a much more accurate visualization. Because over 15 years, that knowledge doesn't just add up. It compounds.
It builds on itself.
You are building a personalized, highly specific search engine for your own brain. When you run into a Unicode parsing error in Rust 3 years from now, you don't have to start from scratch and search the wider, noisy internet.
You just query your own changelog for that time you fixed it in Haskell.
Exactly. But if reducing friction is the secret to sustaining this for 15 years in rigid logical systems like software.
Where doing X usually results in Y.
Right. I have to wonder, does this strict framework completely fall apart when you apply to something messy and organic?
Because the real world doesn't operate like code.
Exactly. You would think the methodology would break down, but the archive emphatically proves that it doesn't.
Yeah, this is crazy.
In fact, how this author applies this mindset to non-technical fields might be the most fascinating aspect of the entire source material.
The project tags here are just a goldmine. Let me list a few of these so the listener can get a sense of the sheer variety here.
Go for it.
Yes, we have Notes on Networking, Part 11, where they are analyzing Wi-Fi 7 protocols, very standard technical stuff.
Very normal.
But then right next to it, we see Notes on Dieting, Part 115, The Truth About Icosa. We see Notes on Fish Keeping, Part 219, and my absolute favorite,
I know which one you're going to say.
Notes on Gardening, which goes all the way up to Part 849.
Part 849 on gardening.
Yep.
That represents hundreds of hours of observation.
It's incredible. It's as if they are treating a garden exactly like a piece of software, but how does that actually work in practice?
It's tricky, right?
Yeah, you can't just type a command and make a tomato plant grow faster.
Well, no, you can't control the plant directly, but you can control the variables surrounding it, and you can apply the scientific method.
Okay, let's look at the archive for that.
We see a bug reported in the gardening system. In Gardening Part 826, the post is titled, Leggy Seedlings Again.
A leggy seedling is a bug report for a plant.
Pretty much.
For anyone who doesn't garden, a leggy seedling is when a young plant grows really tall and thin because it's usually stretching desperately to find light, making the stem incredibly weak.
Now, a traditional gardener might see a leggy seedling, panic, and change 3 things at once.
Oh, I've done that.
Right. They might move the plant to a new window, change the soil, and add fertilizer all on the same day.
Just throw everything at the wall.
Exactly. And if the plant gets better, they have absolutely no idea which of those 3 things actually fixed the problem.
Because they didn't isolate the variable.
Exactly. But the software plumber doesn't panic. They isolate the variable. They run a single patch.
Like a software patch.
Yes. A few weeks later in the archive, we see Gardening Part 845, switching to bottom watering. They introduce one specific change to the system's input.
And then they just watch it.
Then they step back, observe the results, and document whether the leggy seedling bug persists.
It shows that the underlying pattern, the core algorithm of learning, doesn't change just because the subject matter changes.
Not at all.
The same meticulous mindset that replaces an ASCII checker with a Unicode checker is being applied to managing a fish tank. Look at the fish keeping tags. Part 216 is managing dominant behavior in the tank. Part 217 is balancing the goal.
They are analyzing the social dynamics of the fish and the chemical balance of the water, likely the nitrogen cycle, with the exact same rigorous documentation as a Haskell parser.
That is so wild to think about.
They are treating knowledge as a single, unified landscape. We usually compartmentalize our intelligence, don't we?
We totally do.
We think we have our professional, technical skills in one box and our weekend hobbies in another completely separate box.
Right. You don't usually bring your software engineering mindset to pruning your rose bushes.
But this archive argues that you should. Whether you are debugging a parser, propagating a plant, or, as we see in exercises part 17, focusing on healing in a rubber band exercise, the fundamental mechanics of mastery are identical.
Observe the system.
Yes, you observe the system. You identify a friction point. You implement a small, isolated iteration. You find the right tool for the job, and you document it for next time.
In Gardening Part 849, the title is The Effect of Microborer. They are explicitly testing microvariables in an organic system. They aren't just throwing seeds in the dirt and hoping for the best.
No, not at all.
They are running a 15-year, highly documented biological experiment. It really is the scientific method disguised as a personal blog.
And that is exactly why this log is so deeply relevant for the listener.
Yeah.
Regardless of whether you know what Haskell is or if you've ever kept a fish alive in an aquarium, the takeaway isn't about the specific code.
The code is just the medium.
The takeaway is the power of the methodology itself.
We started this deep dive looking at a microscopic tweak to a piece of code, just changing the way a program reads chapter numbers so it wouldn't go blind when looking at Japanese text.
Right.
And by zooming out, we've discovered this massive framework for continuous compounding learning that just utterly defeats information overload.
It is the ultimate counterintuitive shortcut to being truly well-informed.
Counterintuitive because it seems like more work at first.
Exactly. We often think the shortcut is finding a master summary that explains everything at once. A silver bullet.
Give me the life hack.
Right. But the real shortcut is committing to the micro-refactor. Making small, well-documented, robust tweaks to your understanding day after day, year after year.
So what does this all mean for you? Whether you are writing a complex script for work, trying to manage a team of people, or literally just trying to keep a Brazilian plant alive on your windowsill.
Which, by the way, is documented in Gardening Part 842.
Naturally. Whether it's that or anything else, this approach works. You observe, you adjust, and you record. You build your own mycelium network of knowledge.
And, it leaves me with a thought that I honestly haven't been able to shake since looking at this archive.
Oh, what's that?
We've talked extensively about how this methodology builds a personal search engine for your own brain. But what happens when you externalize your knowledge so meticulously for 15 years?
What do you mean by that?
Well, we all go through daily, mundane trial and errors.
Sure.
We figure out how to navigate a difficult conversation with a specific type of coworker. We learn the exact right way to balance our household budget. We figure out the leggy seedlings of our own lives.
Right.
Usually that hard-won wisdom just lives quietly in our heads. And eventually it just disappears with us.
Yeah.
But it makes you wonder, if you rigorously logged every tiny bug and fix in your life,
Oh, wow.
what happens when you hand that change log down?
You mean like open sourcing your life?
Could you literally open source your life's wisdom for the next generation? Imagine handing your children or a junior team member a searchable, tagged database of every mistake you ever made and exactly how you fixed it.
Part 849, Part 94.
Exactly. It transcends just personal learning. It becomes generational knowledge transfer.
You aren't just fixing the leaky pipe in the city for yourself. You are leaving the blueprint behind so that anyone walking past that street a decade from now knows exactly which wrench to use.
Exactly.
That is a truly profound idea to mull over. Thanks for going on this journey with us, and we'll see you on the next deep dive.